Okay, we're going to do a basic trigonometry review. And when I say basic trigonometry, usually what we're referring to is we're going to be working with right angle triangles. Okay, and I've put 3 here for a reason because there are 3 major ratios with right angle triangles that can help us out a lot. Okay, one of them that we're really not going to talk about is actually a formula. Do you remember Pythagorean's theorem?
Yeah.
Okay, so we'll just keep that in mind on the side. Right? It's important to know. The other ones we're going to talk about are sine, cos, and tan. Okay, so we have sine, and I'm going to see if they use theta for you. They do use theta. Okay, good. So sine theta is equal to the opposite over the hypotenuse. Okay, and actually what I'm going to do is I'm going to put these in specific colors, which I should have thought of before I wrote them. We'll leave hypotenuse in black to save us some time. We'll put opposite in red. Okay. Then cos theta is equal to adjacent over the hypotenuse. And finally, tan theta is equal to the opposite over the adjacent. So I've given you some rules, but we really have to make sense of what the heck they mean. Okay. First of all, this silly symbol, theta, do you know what that stands for? No. What it is it's an angle. Okay, now in right angle triangles, we already know one of the angles. So whenever I write theta in, I'm referring to one of the angles. It could be this one or it could be this one. It really depends. Now it's important because depending where theta is placed, that will give us different opposites and adjacents. The hypotenuse will always be the same. Do you know what the hypotenuse of a triangle is, where it would be for a right angle triangle?
The longest.
Yeah, and that's always opposite of 90 degrees. So that is always our hypotenuse. So no matter what we do, this will be our h. Okay? That will always be our h. Now, it's the opposite and the adjacent that can always say. And maybe it's good that we wrote it in black. It's like a base. It never changes. Well, opposite and adjacent can change. So for instance, if I say this is my theta, okay, that would then make which side of the triangle the opposite?
The hypotenuse.
Well, the hypotenuse is touching, so what I want you to think is what side of the triangle is not touching it? It's harder to explain with words.
The bottom.
Yeah, the bottom, or maybe you refer to it as the base or something. The opposite. This would be the opposite. And this would be our, because it's touching, adjacent means to touch, and by deduction, it's the only thing left, right? Adjacent. Now, what if I told you, say it's the exact same triangle, but this is my theta now. I want to work with this triangle. What would be my adjacent side?
The hypotenuse.
Well, hypotenuse is touching, but it's always called the hypotenuse, even if it's touching. So what other side would it be?
The base.
Yeah, the base. This would be our adjacent because it's touching. So the adjacent is the side that's touching that is not the hypotenuse. Okay, so we always put that in first. That's our hypotenuse. It's opposite of the right angle. This is our adjacent, the side that's touching, which by deduction means the other side is what?
The opposite.
Opposite. Good. Now, with that being said, okay, let's put some numbers in, and then we're going to set up these ratios. Okay, so let's say I put theta here. Okay, and I have the numbers, which is a very common triangle to have, 3, 4, and that will be 5, and they'll all be centimeters. Okay, 3 centimeters. If that's the case, I want us to set up each ratio. I don't know what theta is yet. I haven't figured it out. Okay, but sine theta, so if I were to ask you what is sine theta equal to, you have to tell me, well, first you know it's the opposite of the hypotenuse. You got to tell me the numbers, okay? So, let's say we're talking about sine. Sine theta is equal to what? The second one we'll do is cos theta is equal to what? And then tan theta is equal to what? Okay? These can be hard to memorize, so before we get into that, there's a little Sohcahtoa, so it's considered an acronym, okay? And they call it Sohcahtoa. So the SO means S-O-H. It helps you remember that sine is equal to opposite over hypotenuse. Co is C. Sohcahtoa. Sorry, I shouldn't have said co. I pronounced that wrong. Ka, C-A-H, helps you remember the cosine ratio. That's cosine theta is equal to adjacent over hypotenuse. And Sohcahtoa, green. Toa is T-O-A. Okay? So a lot of people write it this way. They'll write, if I can do it in yellow, S-O-H. Can you kind of see that?
Yeah.
Yeah. Ka, Toa. Okay, and that's a way that we use to remember it. So we have our Sohcahtoa. So with that being said, maybe we should zoom out just a little here. What would sine theta be equal to? What numbers? What over what? Take a look, and we're going to talk about this triangle here.
Okay.
So from that theta there, in the top left corner, excuse me. What would it be equal to, do you think?
4 over 5?
It would be 4 over 5. Yeah, exactly. Okay. Do that in black. 4 over 5. Perfect. What about cos?
3 over 5?
Yep, 3 over 5. And then?
4 over 3?
Yeah, opposite over adjacent. 4 over 3. Amazing, you got it. So now what I'm going to do is I'm going to change this a little. Okay? We'll use that same type of triangle. I'm going to use the same measurements. Okay? But in this triangle, I'm only going to change one thing. 4, 3, 4, 5. Okay? And now I want you to give me sine theta, cos theta, and tan theta. So starting with sine, what is it equal to?
3 over 5?
Yep, 3 over 5. Cos would be
4 over 5?
yeah, and then tangent.
5.
What does tangent stand for?
Adjacent over.
It's not adjacent over, it's actually opposite over adjacent. So which would be the opposite here?
The 3?
Yeah, so 3 over
4.
yeah. And again, let's maybe zoom out just a little. Okay. I want to show you the relationship. If you notice, same triangle, okay, this one and this one, same triangle. But when I put theta here, sine was 4 over 5. When I put theta here, sine was 3 over 5. And see how they're kind of related to each other? They end up kind of being opposites, right? And then these two tangents are opposite of each other. They flip. Does that make sense?
Yeah.
Yeah, okay. Oops, other one. Okay, so let's say you're going to use your calculator now to solve one of these. Scroll down. If I had given you just an example here, call it example A. Okay, if I had given you something like sine 30, so that's the angle, is equal to theta, that's the side where, actually no, I shouldn't use theta. Theta represents an angle. So x over 5. Okay, if I was to recreate this triangle, pretty much what I'm doing is we know it's a right angle triangle, right? So that's a right angle. Okay, one of the angles is 30, so maybe it's right as this one. What's 5? What does that stand for? What part?
The hypotenuse.
Hypotenuse, or hypotenuse is 5. And x would be which of these sides?
The base.
The base, yeah. And then we could kind of put this into an equation. We'd isolate for x, we'd bring 5 over, so we type in sine 30, multiply by 5, and it'd give us what x is equal to. And I can show you quickly on a calculator what that would look like. 30 sine times 5, 2.5. So it turns out x is 2.5. Okay, and then we can use that same information. We can make it cos 30 to solve for this side. Right? Okay, but let's say we're solving for theta. Okay, well, this kind of looks like it's multiplication, but actually this is a complex equation. Okay, and it's putting a number into a complex equation. So we don't really divide by it. In fact, we can't divide by cos or tan or theta. If we do it in our calculator, 2.5, I'm going to say divided by cos. It didn't really work out, but it shouldn't have worked out. How can I explain that? Oh, because this calculator does it the other way, 1.3 divide. I don't know if this will do it. Nah, it doesn't quite do it. The calculator ignores my mishit with theta, but normally you can't. It's not the way that would work. So what we do to isolate for theta is we do the inverse. So if I want to move sine or cos or tan to the other side of the equation, because we want to isolate for our unknown, right? Just like we isolated for x up here, you want to isolate for the unknown. Well, when you do that, it would become theta is equal to the inverse of that function. So it looks like that on your calculator. And then you'd have whatever this number is, that inverse. So theta equals, again, I'm going to write the inverses in after, okay? And theta equals, again, and these, it would be cos inverse and tan inverse. So on our calculator, we should get the same answer for all of them, really. I would type in 3 divided by 5, okay? And then see, sine right now, it's just sine. It doesn't say that to the power of -1. So I probably have to hit a shift. In mine, it's like an upwards arrow. And when I do that, it changes it to sine -1. And when I hit this, 36.86, okay? So it's telling me that theta is equal to 30, did it say 38 or 36? 36.89, 36.89, okay. Now let's test this one. Because it was the same angle every time, I should get roughly the same answer. In this one, it was, so we'll clear it, 4 divided by 5. And we have to do cos inverse, 36.86. Really, really close, right? And then let's test the last one, 3 divided by 4. Okay. Tan inverse, 36.86. So we found the same angle every time. So when we're typing these in, essentially your ratio of your triangle follows that to help us solve for the angle. Okay? Does that make sense?